Hello, this is Tim Schneider. I'm a senior FAE with Vector North America, specializing in VectorCAST. Today we'll be looking at using QEMU with VectorCAST. So what is QEMU? QEMU is a generic and open source machine emulator and virtualizer. It emulates at the board level, so CPU, devices around that CPU, memory maps, etc. This can benefit Vector users in a number of ways. Primarily, we use it in unit testing. It's very easy to convert from existing hardware or debugger-based RSPs, runtime support packages, that have to maybe go out over a JTAG or start up a debugger that can take a little bit of time and run directly on these virtual processors, on these emulated boards. When we set these boards up in QEMU, we can virtually make unlimited RAM and flash. So memory size for a memory constrained M0 is not really a problem anymore, and it's very fast because you're running at host-based speeds, the speed of your PC versus going on to some 25 megahertz processor. It can also be used for host-based test platform testing in an RTOS, like QNX uses this, DDCI DOS uses this, and it's open source and free. And maybe the best part about it is compilers. There's no special compiler needed. You can use your existing ARM compiler, say. If you have something that's targeting an STM32, Cortex M4, just use that same compiler and use the matching QEMU board that goes along with it. You can use your existing code. There's no converting to a special simulator, or say you're trying to run it on an x86 from an ARM. You don't need to make fake header files or anything you would typically do to run a hardware-based solution or a debugger-based solution a little more quickly. What architectures are supported? Well, some of the primary ones we see: ARM, ARM64, PowerPC, Tri-Core. There's so many more out there. You can look at the QEMU docs and find that. Within VectorCAST, we've already supported a generic ARM, M0, M3, M4, M7, A9, and A53 for the generic QEMU. We support QEMU for Xilinx Zinc 7000 and ZCU 102, and those are the Cortex A9, Cortex A53, and Cortex R5F. And then with on the PowerPC side, we use the QEMU emulator provided by DDCI for the DOS operating system. So what is it that you need to run QEMU? Well, basically, you guys already have the compilers figured out. You're using ARM-based compilers. So just go to qemu.org/download and download it and install it. For me, in this demo we're going to see in a minute, I'll be downloading and installing mine in C/QEMU. And that's it. So let's jump into the demo. The first step is to download QEMU. So if you go to qemu.org, and then from there, go to Downloads, select your platform. I'm on Windows. So then we can go and grab, for my system, the 64-bit installation. And we'll just grab the latest one. QEMU supports a number of different architectures, but in this specific case, we're going to be looking for the ARM architecture. And once it's finished downloading, you can just open the installer, select your language, and start installation. I'm going to put mine somewhere easy for me to remember, so just in C QEMU, but you can install it wherever you'd like to. So if you look at the install, it's fairly straightforward. The QEMU editions are down here. You can see ARM right here, and that's how we'll set this up. So we'll need to actually set QEMU to our default path. So I already have a basic batch file set up. I can add the path to QEMU, and then I can run the batch file. So from here, I can create a new VectorCAST project and call it QEMU demo. For compiler, let's go ahead and pick a GNU target, and we'll do bareboard and ARM, and we'll do, say, an M7. In this case, we've set up for the MPS AN500 QEMU emulator, and we'll pick a C environment. And then our base directory, we'll just do VCAST, and the current one that I'm running is SP8, and we'll do tutorial/C. That'll be our base directory for the demo. You can come in here and create a new environment interactively. You can see that we've already populated everything we need for the compiler, for the execution method. So we'll just go ahead and name this QEMU demo. We'll use our standard testing method. We'll set the coverage for statement and branch. White box. We'll locate the source code that we want to use, which we've set as our base directory, and we'll pick up manager.c and go ahead and build. We can add a test case in, seat 1 and table 1. This is our standard restaurant menu, and we'll go ahead and get a steak, which for the expected values, we can use cost of steak, and then go ahead and run that test case. And you can see that it executed the Python script, and we're calling out the specific QEMU emulator that we want to use. All the commands are already set, all the ports, all the timeouts, and we can go ahead and run that. And when we ran that, what we ended up with was code coverage for the state case. So if we want to add in maybe just to get the rest of them, we can do that and just run the entire list of test cases that we created. Now, a benefit of QEMU is it's a very fast execution method. We're not loading up through a JTAG device running at processor speed. We're actually running at our host speed to do this. So you can see those test cases executed very quickly, and we have 100% coverage. So that's how you do QEMU within VectorCAST. Thank you very much.